Okay.
Yeah.
Okay. All right. So first and foremost today, we're going to be moving on to chapter 3. I know we just took the chapter test on 2. Some of you still have to finish. That's fine. Chapter 3 is actually really incredibly short compared to the other chapters. Chapter 2 I consider kind of long. It was 8 sections. There was a lot of proofs and stuff. That chapter is insanely hard compared to this one. This one's a lot more simple because of the stuff we're going to be learning. I think there's only 5 sections, and we're going to do this first section today and tomorrow. Like, it's quick. I'm expecting a test over this chapter the first, second week of December. First, second week, something like that. So, I mean, that's quick, right? So that's what you can kind of expect. Now, why I'm warning you of that is so you know, like, after Thanksgiving break, you need to be buckling down because we're going to have a test, you know, that first week or second week of December, and then we're going to move on to chapter 4. We do have a semester test, and I got to check with the administration what the dates are, because sometimes they allow us to have them before winter break. I like to have it before so you don't forget everything. I usually try to put mine the Thursday before winter break, and so you'll start to get the practice guide for that here coming up after Thanksgiving. I usually give it, yeah, it's next week.
Is it actually?
Yeah. So I usually always try to give out the practice guide a couple weeks in advance for that, 3-4 weeks in advance. So you'll probably get it like after Thanksgiving break. The semester test is for me, it's about 15 questions. It only covers the test questions, so about 15 for me. It covers chapter 1, 2, and 3, and then obviously we're going to be in a little bit of chapter 4. So it'll be whatever we cover in chapter 4. But it's not everything. It's just I picked what were the major things we were supposed to learn, the big bullets, and I put those on the test. Now, just to give you a fair idea, like why give 15 or less problems? Because I don't do multiple choice. You have to show some math that you can prove certain things, or you're going to do some problems. So I consider it pretty easy because we'll review for 5 days leading up to it. It's over the stuff, and we'll do, the review is usually I do like second half of class, we review each day, I pick like 1 or 2 problems or 3 problems to review.
So like the semester test?
Yeah, semester test.
So the semester test is like a month.
Yeah, about a month.
That's actually insane.
Yeah, so, now, that's if the administration allows me to take it before. If we don't get it before break, let's say administration says it has to be after winter break, then I always do mine the Thursday after. So it's the Thursday when we get back, that way we get a couple days review, get back in the swing of things, review a little bit, and then we'll take it. Okay. Now to give you an idea, every class has a semester test. Every single one. You got to be mentally prepared for that. Science tests. They're like 200 questions.
What?
The science ones, because they're all multiple choice.
Any of them. Science test was not that long last year.
So it depends on what science class you had.
I'm sure. I had
So,
good at science.
Yeah. Biology is long. Okay. Okay. Hey. Okay. Question.
I think that after Thanksgiving break, we should just link it right to Christmas and New Year's break, and just not go to school in December at all.
All right. Now. All right. Now, hey. Okay. All right. So we're going to be talking about parallel and perpendicular lines throughout chapter 3. That's kind of the idea. We're going to come back to these pictures, off and on today. My goal is to do just a few notes today, a few notes tomorrow. We'll probably get an assignment possibly tomorrow, just because it's just based on vocab. We don't have really any crazy difficult stuff. We're not doing proofs or anything like that. So it's pretty straightforward. It's pretty easy. We're getting back to the easier stuff again. Now, chapter 3.1, this is the title of the section. You want to write this down. Today, we're going to talk about parallel lines, and we're going to talk about transversals today. So you need to have those two written down. We're going to kind of walk through the idea of what to do here. Okay? All right. So chapter 3. Okay. Here's the basic thing. Let's review the major words we need from the first couple chapters because we've done chapter 1, chapter 2, right? So major definitions we need to know going into this chapter. Obviously, we need to know what a line is. Okay. Now, what does it take to draw a line?
Straight line.
Okay, straight. How many points?
2.
2. And does it stop?
No.
No. So here's the idea. It consists of 2 points, extends in both directions without limits. Keeps going. They have arrows. Right? Now, think about this, like, why am I reviewing this? If we're in a new chapter and we have some words from previous ones, I try to review them with you. We've been carrying the word perpendicular through every chapter, so line has been carried in every chapter. Now, When was the first time I introduced what a line is?
First day.
First day of class, and I'm joking. It was section 1 of chapter 1. It was first day we talked about what a line is, points, lines, and planes. Okay, yeah. So, 2 points, extends in both directions without limits.
Good point.
Okay, we need to know that, right? A plane is consists of how many points?
3 or more.
3 or more. 3 or more points makes a plane. So what the book says, they have to be non-collinear. Collinear means in a straight line. They have to be not in a straight line, and that makes a plane. Okay? They do not have edges. They have no edges, so this thing would extend. And again, that word plane was on the first day of class back in August 22nd, I should say, when we introduced planes. You know, 3 non-collinear points, extending to have no edges. Section 1, chapter 1. These words are the major words we need to have throughout chapter 3. Like, they're it. Those are the words we need to know. There's other vocab we're obviously going to get, but if you don't know what these are, you don't know the rest of the stuff. We're going to build upon these words today. Now, obviously, we're going to start with, we're going to talk about parallel today. We're going to review what that word means, introduce it, know the symbols and all that good stuff. But then we also have to talk about what a transversal is, because that applies to these pictures and it makes other things we're going to need throughout chapter 3. Okay, all right, questions with the 2 words from the previous chapters? Now, obviously, the major help for these 2 words is just for Gabby. She hasn't been here from chapter 1, so she needs to see those. Okay, all right, let's move to the next part. Let's talk about what parallel means. We've actually had this word back in chapter 1. We need to redefine it, because we're going to add some new parts to it now, because we've added some more vocab words since then. So, definition of parallel lines. Parallel lines have 2 check. There's 2 checks that we have if you know lines are parallel. Number 1 check, they have to be coplanar. And the second check, they can't touch. They do not intersect. Those are your 2 checks.
Coplanar, that's when they're on the same plane, right?
Yes, and I'm going to write that down. This means same plane. That's the best way you can put it. So your lines have to be on the same plane, and do not intersect means?
So really, there could be
don't cross.
10,000
They do not-
parallel lines as long as they're straight.
Yep.
lines or straight.
Do not cross or do not touch. So
And
these are your 2 checks.
That's what I'm.
So they're on the same plane, and they don't touch, they're parallel. They have to be on the same plane though. So let me give you an example of this. Here's your picture. And that's the picture I showed you earlier.
Like the road.
So,
Oh.
So, yeah, I have a bunch of lines here. Yeah, we'll get to the roads. That's actually the example we'll look at tomorrow. So on this picture, 2 of the lines are actually parallel. There's 3 lines. Which ones?
Line JK and
JK?
line LR.
Yep, JK, that line, and this is how you write lines. You write 2 letters, you put a little bar above it. That line is parallel, and now notice the symbol, is parallel to LM.
So they could,
They use the little railroad track symbol to mark parallel. Now, the other thing from the picture, yeah, the pink arrows. I knew somebody was going to ask it. The pink arrows, that means that those lines are parallel. Or if it's pink or purple to you, if you're colorblind, sorry, it's the big arrows that are in there. Those lines, those little symbols, mean that those lines are actually parallel. It doesn't mean anything else. They're not the same size or anything like that, because obviously we don't measure lines, but they're parallel. They're like railroad tracks. They're not going to touch. They're on the same flat surface. Now, the only other line that is not parallel is JL. JL crossed both of them. That's another word we're going to see later. Okay, any questions with what parallel means and how the checklist for it? 2 parts. Same plane, do not touch. Okay, does everyone know the symbol?
Yes.
A lot of the chapter 3 has symbols. So like, we're going to talk about parallel today. Tomorrow we'll talk about, or maybe later sections we'll talk about perpendicular again.
So when there's arrows, that means parallel.
It means parallel. So that's for the picture. This is if you're writing it notation wise. Okay? Alright. We're going to get back to this idea of the parallel idea. Okay? Alright. Now, let's talk about the other things. Now, there is a possibility, I know this is going to seem really weird. There is a possibility that, hey,
Kelsey, pay attention.
so, there is a possibility that we could draw lines where they're not parallel and they're not intersecting either. And I know that really weirds people out. Like, it's not parallel and it's not
Oh,
intersecting.
they're like this.
Len, what do you got?
they're not on the same plane.
Yeah, they're on different planes. So that's the idea. So they're called skew. Okay? Kevin, you got a question?
So like, from your definition, it says like coplanar,
Same
not
plane.
intersect. So then they could be windy if they don't touch.
No, they have to be lines. It comes down to the lines, straight.
So they don't touch and they don't what?
We're not talking about
How
curves.
is a road parallel then?
Road, if we're talking about straight lines, they can be parallel. The lines on the road itself. Like if you print it, like we're talking about straight. I'm not talking about a curve. That's conics. We talk about that later.
Did you know that each of those yellow lines on the road is 10 foot? Yeah.
No.
Yeah, I got out on the road like one time because I told my dad that we pulled over.
That's good. That long?
Yeah.
Huh, they don't look that way.
Well, probably because you're driving
Um,
60 miles an
What
hour.
would,
and it's
what would
like-
happen if like on a plane, there's a line on the side and then there's one line going through?
We'll talk about that.
Little yellow
That's
line.
what we're talking about here. Okay. All right. Hey. Okay.
Wait,
Skew.
10 feet long or 10 feet apart?
Okay.
10 foot long.
No,
Couple
the dotted,
No,
the dotted ones.
Wow.
The yellow line. 10 foot.
Two foot.
No, they're
Let's
definitely
stop
10
talking
feet
about
apart.
roads.
Okay.
No, 10 foot.
Hey. Hey.
No.
Discuss it later. It's an interesting topic.
Let's get
Talk about it
Google
later.
Maps.
Okay.
It's not 10 feet.
Hey. Okay.
It's not longer than 10 foot.
Hey. Okay. Okay, for skew. Skew lines, this is the one we were just talking about. They're non-coplanar. They're not on the same flat surface, but they're not parallel and they're not intersecting either. Okay, they're not parallel and they're not intersecting. They're called skew because they're not on the same flat surface. So the picture the book always uses is they use this idea, and this will get to your question there, Brandon. It could be a three-dimensional picture. So they show like a picture of like a sugar cube or a die, like a die that you roll. And they talk about the certain lines that are on that picture. So for instance, the front, the front line, which is like CD here. So CD, and then you pick one of the lines in the back, like FG, the one going up and down. So this is like what Isaac, you were talking about earlier. If the lines are going different directions, so this is like a 3D image of where they're at. One's in the back and one's in the front, but they're not parallel. It's not like railroad tracks. They're going different directions, and they're on different planes. This line is in the back, this line's in the front, and they're going different ways. Now, Brandon, you were talking about like what if there's a line here and a line going through it? Same thing. They're not touching, so they're not parallel, but they're not intersecting either. Now, if you picked EF and CD, they are parallel. They're railroad tracks. They're on the same flat surface. Or I had it in I think second or third period today. I think Brock talked about CD and HG. Even though this is in the front, this is in the back, they are still parallel. Because if you move them, they're actually, there could be a plane that could touch both because they're going the same direction.
Every line has a circle around it that is parallel with it.
What was that?
Every line can have a circle around it that is parallel with it.
Every line could have a circle around it?
Well, like here.
Oh, you're just talking about,
Like an area.
yeah, we're just talking about straight lines. We're not talking about curves though. No curves. I'm just talking about in general, when we talk about parallel, they have to be like railroad tracks.
He's kind of,
Connex,
he's
it's
kind of
the
talking
opposite
about like an
skew.
area of effect.
Yeah.
Where it could be.
Yeah, I'm talking about straight lines. I understand that you're saying that there could be an infinite number of lines that are parallel to it. It doesn't matter where they're spaced. So that's why I'm not gonna say like a circle,
Yeah.
because they could be any
It could be,
distance.
like, this far. Or this
Exactly, they're still parallel. So that's why I want to avoid that. Okay, all right. Do we understand the difference between skew and parallel?
Yes.
Okay, parallel, they're on the same flat surface. Skew isn't. That's like the major key term there. Now, let's talk about how we can apply these to different pictures. So, obviously we talk about parallel lines. We should talk about parallel planes. Okay, so planes can be parallel to each other. They can be parallel planes. Okay, so here's a picture. The idea is that they don't touch. So there's my picture of my planes. So that's plane A and plane B. Now there is notation for this. So how you write this? You can write plane A is parallel to plane B. So I can write it like that, where I use a little parallel symbol. Now, here's the weird thing, right? Plane A and plane B. Do you notice that there's lines on those planes?
Yes.
Those lines, these lines, so I'm going to draw, so here's that line, here's this line, right? Those lines, L and M, are those parallel?
No.
Why?
They're
Exactly. They're on different planes, and they're not going the same direction. One's going kind of north-south, one's going kind of east-west. They're going different directions. They are definitely not parallel.
But if they were both going,
If they're going the same direction, they potentially could be. If they're going exactly the same, because you could draw a plane that connects them both. Even though it's not drawn, there is a plane that would go through them. But these, in this particular instance, even though the planes are parallel, You could have lines that aren't.
You can't have skew planes, can you?
Skew planes, no, because they would intersect. So, question.
Are planes circles?
Planes? No, they're flat. Flat surfaces.
So they just
They
go like
extend.
out through the atmosphere.
Yeah,
they
just-
don't like go around the Earth.
Nope, they just extend flat. So. Okay, alright.
Do you ever like think before you get information?
Okay, alright. So, hey, let's walk through the different cases what we could have here. So, so we talking about these, even though the planes are parallel, the lines aren't. There could be a situation, and Isaac, this answers your question that you were asking earlier. There is a way that you could draw a line and a plane parallel to each other, where you could have a plane, you could have a line somewhere else that isn't on it. They could be parallel because they don't touch each other. So that was kind of answering your question that you could put lines that are parallel and they're on different planes because you could draw a plane that connects them together. So it's just if they're actually parallel itself. Now here's the other weird situation. If I draw segments, not lines but segments. So let me put this example here. This is really the question I want to know before lunch. Okay, so CD, there's a segment, and AB. Okay, so there's segments, right? Are they parallel?
No.
Okay, so let's talk about this, right? Because there was a checklist for being parallel. What were the two things we had to check for?
They don't touch.
They don't touch,
Lines.
they're not touching,
They're on the same
They're not
plane.
and
lines.
they're on the same plane.
Boom, they're parallel.
They're not lines.
Okay, all right.
That doesn't matter.
That is the number one thing. Okay, now the checklist for parallel, right? The checklist for parallel. They're on the same flat surface they're on my marker board. They're not touching, as you can see. But what Kevin said, they're not lines. And if you look back to all these definitions we talked about, I'm only talking about planes and lines. Planes and lines, that's it. This picture are not lines. To figure out if these segments are parallel, to figure that out, you have to extend them further to make them lines.
So they're not.
So you have to extend these further to make it a line, so you just draw the little dash line to make them longer, use your little straight edge, and eventually they'll meet over here somewhere.
So you
So,
technically
they're not
can't
parallel.
tell.
Right now, you can't tell until you extend them to see.
Because they could be
So,
like, one could be like 90 and one could be like 91.
Yeah, so
You
you have to
wouldn't
extend
tell.
them, and eventually you have to see if they actually make it. How you know if they're going to be parallel or not, they'll put the little pink arrow things that we were talking about earlier. That's how you know, like, maybe these segments are drawn like this, and you can't tell, like, it kind of looks good, but if they put the little arrow, automatically parallel. Even though they're segments, if you extend that little arrow means that they are parallel. So that's one way you can get around it. So you don't have to, like, kind of think about it.
So technically, it doesn't matter what we perceive. One could be like this, one like this. But
Yeah.
if they have arrows.
Yeah, if they have arrows, they're parallel. And they have to have the same arrow. Because you can have multiple different lines on a picture. They'll have, like, matching arrows. You'll see it. Question?
So like in 5th grade when we had like math books and stuff,
Yeah.
and they had like the segments, and I was like positive they didn't have arrows on it,
Yeah.
and it said like, is this parallel?
You'd have to
And we
extend
should've
them
said
further.
no.
Yeah, you have to extend them further to see do they actually touch. So technically the answer would be no, if they're pointing at each other, kind of thing. Even though like by definition it didn't meet both bullets, right? They're on the same plane, they didn't touch. But for it to be parallel, they have to be lines, like you said. Okay, all right. So and again, lines contain them are not parallel. Now, what we're gonna do before lunch, because this is my last little slide here. Yeah, we're gonna get to pictures like this where I have multiple lines crossing. We're gonna get to that, right? All right. The goal in chapter 3, what we're gonna be getting into, right, is to talk about parallel, perpendicular, right? So parallel, what we've been talking about is using the vertical bars, right? These little tall bars. They're not absolute value bars. They're just tall up and down bars. We can say that objects are parallel, like these planes. I can say that in words that they're parallel, or I can use little symbols. Those sentences mean the same thing to me. Okay, does that make sense?
Yep.
Okay, when we get back from lunch, we have some more words. Okay? Okay, hey, okay,
It's right here. Ah, I got you.
all right. Hey, let's walk through a couple things here. So Kel's, I put it on the floor, so it's down there. I don't want to trip on it, I don't want to knock it over, it's already broken. So. All right, so what we're talking about before lunch, we're talking about parallel, right? We had parallel bars. We could write it with word sentences or with the bars itself. Let's make sure the hooks get off. So, All right, so let's talk about some vocab terms here. All right,
Hey!
so,
It's closer to you than I am.
okay, all right.
Is that home?
Words you need to write down today. We're going to do half of these today, half of these tomorrow. These are the vocab words in order that we're going to go through. So, and we're going to come back to this picture, and this is kind of like, it's got a lot of crossing lines. We're going to talk about the angles that I've numbered here. So that's going to be, we're going to come back full circle to this picture, and we're going to talk about them, okay? All right. So, first word we're going to talk about. Stop. Okay. So, we're going to talk about transversals. We're going to talk about interior angles. We'll talk about exterior angles. We'll talk about alternate angles. There's two types of alternates. We'll talk about that. That's one we'll probably stop at today. We'll do the first one. We'll do the second one tomorrow. We're going to eventually talk about same side angles. Now, I put interior. There's actually two types. I should probably change that. And corresponding. Okay? So that's the idea that I want to cover today. So I want to get through about the first term here. So we're doing about half of them today, half of them tomorrow, and then we'll eventually look at some homework with this stuff. And it's just based on, can you look at a picture and tell me which part's which? Okay, now, we need to get through the words. Now, obviously today, we're talking about parallel. Eventually, like, these don't look parallel. Eventually, we're going to move these to actually parallel lines, and then there's going to be some special properties that are involved here. That's what we'll talk about later on down the road, which I think is pretty straightforward, pretty easy, but I'll kind of give you a hint on some of that stuff today. All right, so let's get to the first word here. We're going to start with transversal. I'll be in my next slide. We'll define it. I'll show you a picture of it. We'll get to the next word, show a picture, define it, all that good stuff. So, first word here, transversal. Here's your definition, like you write down. It is a line, segment, array that intersects two or more other lines. So let's write that down. I'll give you a picture. The picture I found online is just to help us out. I like the labels that they had on it. So we'll talk about it today. So it's a line, array, or segment that intersects two or more other lines. That's a transversal. In fact, we need a transversal to even have the other words that were on that list. Like if you don't have a transversal, the other words, interior, exterior, alternate, same side, and corresponding, those won't even exist without this idea. Okay? All right, so I'm going to give you a terrible picture. I found this online. I just like it the way they labeled it. So here's my lines. So I have Q and R, and we do have a line T going down through them. The line T here is the transversal, so they label it with a T for transversal. This line crosses two or more others. Now, here's the weird thing. When you look at this picture, now I know it's deceiving because it kind of has this weird parallax effect to it. Well, let's imagine that it was flat, just drawn right on the board. There's no three-dimensional part to it. Let's imagine that's flat. Are Q and R parallel?
No.
No. You know, if that's flat, that is definitely not parallel, right? They're on the same plane. They're definitely not parallel. So in fact, the weird thing is, if this picture was flat, Q and R are also considered to be transversals. The book only says line T, but if this is flat,
They kept going.
yeah, these would keep going, they would meet. So line Q actually does hit two or more other lines. It would hit T, and it would hit R eventually. So line Q is also transversal. And line R would be, because R hits line T, and it hits Q eventually. So this line R would hit two other lines, two or more. So they're all transversals. Now, I believe the picture they give you in the book here, this is supposed to be three-dimensional. I don't really see it, but whatever. Okay, so
I see it.
I think it's supposed to be like a wall or something. All right, whatever. But anyways, it's the transversal's line going down. It's crossing through. It doesn't have to be just up and down. It could be side to side or at a kitty corner. But
This
So that's
is
it.
in front.
okay.
It's like Q and R are like the bottom of the door.
it's heading.
Yeah, I know it's three-dimensional. I don't know. All right. Yeah, maybe it's like top of the doorway, bottom of the door. Maybe you're looking top down. Okay. All right.
Oh, I see it. It's like a carpet.
Yeah.
Green is a carpet.
Yeah. There you go. All right. Hey.
It's a red
Or
carpet.
it's a
but it's
wall.
green carpet.
No,
Okay.
it's like the wall.
I heard a message
Hey.
for you to stop talking.
Okay. All right. Hey. Here we go. Next one. Interior angles. Okay. Interior. I'm gonna use the same picture that I just showed you a little bit ago.
Don't even do that.
Interior is angles on the inside or interior of two horizontal lines. Now the book says horizontal. They don't have to be. They can be vertical. They can be at a slant. But they're angles on the inside. And again, to make an interior angle, you have to have a transversal.
So
So-
transverse is just hitting two.
It's hitting two or more others. That's all it is. And we need it to make these. So I'm going to go back to that same picture I was just showing you a little bit ago. but these are angles on the inside. They say the word horizontal, it doesn't have to be horizontal, but here's the picture I showed you a little bit ago, right? So imagine these are horizontal, right? This is the transversal. The interior angles, I kind of have them labeled here. The interiors are the ones on the inside. So imagine like this is like it's a sandwich, right? Top and bottom of the bread. The interior is the inside of the sandwich. So that's 3, 4, 5, and 6. Those are interior, and they kind of have them labeled with different colors there. Okay? So angles 3, 4, 5, and 6. Those are interior angles. Okay, does that make sense? Now, the reason I bring this up, why these are important, these 4 angles, so I'm going to circle in here, these angles are actually related to each other. Eventually, that's one of the properties we're going to get in this chapter 3, because chapter 3 is pretty short.
I have to make 180. That was.
Well, we're going to talk about that. Like 3 and 4, 5 and 6, they have to make 80s, 180s and stuff. But certain angles on that picture are actually equal to each other. So that's what we're going to talk about. So yeah, we'll talk about those eventually. Okay? All right. Question.
If the angles, like, if that line is at a 45-degree angle,
Yeah.
is it vertical or is it horizontal?
This?
Yeah.
This 45? It doesn't matter. It's just if as long as they're going like side to side, that's horizontal. Vertical is going up and
Well,
down.
like, how do we know if
So-
it's really close?
It doesn't matter. That's what I said earlier. It doesn't have to be horizontal lines. It can be vertical
Okay.
for it to be interior. So in fact, let me just draw it differently because I know I get a lot of questions on that. If I draw the 2 lines going vertical and I draw the transversal going through, this is my transversal. And let's say I number these: 1, 2, 3, 4, 5, 6, 7, and 8. Which angles on this picture? Which angles up here are now interior?
2, 3, 7, 6.
2, 3, 7, 6.
it's fast.
That's interior. They're on the inside of the sandwich, the bread.
I know. She gave
Okay,
me
that's
a hug.
interior. Okay, we good? All right, let's move on. Okay, we're moving on to the next type. Exterior. Okay, exterior angles, and I'm going to come back to that same picture again for one more. Exterior angles are angles on the outside. The exterior of your horizontal lines or vertical lines, it really doesn't matter the type. I don't know why the book types horizontal, it doesn't have to be. But angles on the outside of the picture. So here's the idea. So if I give you your picture, again, the angles on the outside on this particular problem are the 1, 2, 7, and 8. Those are the angles on the outside because they're on the exterior. So if you think about bread, so like you have your little sandwich, the exterior of the bread is the top and the bottom of the bread. Like that's where your hands would touch, right? When you're holding on to your bread. So that's the idea. So those are exterior angles, angles on the outside, not squeezed between. Question?
This is kind of off topic.
Then hold on to it.
Oh,
So-
it is, but it is.
Okay, no, hold on to it then.
Why would you
Okay.
say that?
It's not about exterior.
No, so talk about it later. I don't want to hear about it.
Same.
Okay.
It's not transverse.
So I'll just leave it there. 4, 6, 5, and 8. Just kind of some random numbers. All right. So now, even if the lines go up and down like vertically, which ones are exterior on that picture? The one I just drew.
1, 8, 7, 4.
Good. 1, 8, 7, 4. These are the exteriors. The interiors are the ones squeezed between the parallel walls, or the ones that look somewhat parallel. These are the exteriors. Okay.
Yeah.
All right, again, what we're going to learn in chapter 3 is that 1, 8, 7, 4 in this particular picture, there's a relationship there. If I have one of the numbers, I can actually find all the other 3. If the lines are parallel, that's what we're going to be talking about. Okay, that's why they introduced like parallel in the beginning, because we're going to start making these lines parallel, and there's a bunch of properties that happen because of it. Okay, last word today. Here it is. Last word. Okay, it's alternate angles. Now, alternate, the book has this very generic way of just defining it. I'm going to go more specific because there's 2 types of alternates. So here's what the book defines it as. Angles that are on the alternate sides of the transversal. I know that's a little weird that they used a word in its own definition. It happens. There's some words in the Webster's Dictionary that use their own word in the definition. But the idea is that angles on the alternating sides of the transversal. So if I give you a picture, I'm going to go back to this original picture I had up here earlier. In fact, I think I have one, in fact. Yeah, okay, I'm going to use this one. So on this particular problem,
1, 8.
this is the transversal, right? This is the transversal. Now, there's 2 types of alternate. So I'm gonna be focused on one specific one. So the alternate that I want to focus on today is called alternate interior.
Oh, 2 seconds.
So alternate interior angles. Now, for this to work, there's like a couple different checks you have to figure out what the pairs are. Number one, they have to be on the alternate sides. Hey, stop guessing. Okay, so alternate sides of the transversal. So that means, number one, they have to be on the opposite sides. So that means opposite side of the transversal. So in this particular picture, one has to be top, one has to be bottom. Because that's, the transversal's going this way, so top and bottom are the alternate sides. So opposite sides, that's the key term there, okay? The second check, it has to be what they say interior angles. So the options there, if I'm picking from interior, there's only 4. So it has to be an interior angle because that's your keywords there. The third type, the third checklist, is that, and this is the one that a lot of people don't think about, they have to be non-adjacent. Non-adjacent. Adjacent means next to each other. These have to be not next to each other, so not touching.
2 7.
So yeah, 2 and 7 is a perfect example. These are my interior. These are the interior angles. They're squeezed between the lines that are somewhat parallel. They're not quite. Now, the alternate, one has to be top, one has to be bottom, and they have to be not touching each other. Like 2 and 6 are adjacent. They're side by side. I don't want those. I want ones that are non-adjacent, not touching.
So
That's an
exterior-
alternate interior.
or alternate exterior be 1 and 8 then.
1 and 8. Now, you can also do the other pair. Maybe you're the 3 and 6. But that's the idea. And eventually, we're going to go through properties that explain why those are related to each other. Okay, but that comes later, and the walls have to be parallel. Like this picture, the walls are definitely not parallel. But that's what we're going to talk about. Okay? All right, tomorrow. You definitely need your textbook tomorrow. We're going to do a book check tomorrow. We're going to get a little bit of homework on this stuff to make sure that you're paying attention to the vocab for, which ones are alternate, which ones are exterior. I'm going to go back to that original picture I showed you earlier with all those crazy numbers, and we'll talk about that. Because right now I've been giving you very easy problems. I want to give you a more difficult type of problem later.
Oh, so we need like our physical textbook.
You need your physical book with a book cover on it tomorrow.
Oh, okay.
Okay?
I don't honestly.
Everyone should have one. You need to go find it tonight.
I have.
All right.
5 tomorrow. Like,
Can you remind